So this unit we're going to start talking about triangles and all of their different parts. For the first ones we have a set of triangles here. Oh, this is 3.1.2. We have A, B, C, D, and E triangles, and there are different kinds of triangles going on here, and we're just asked different questions. So the first one asks about acute triangles. Acute triangles have angles that are all less than 90 degrees. So that's every single angle. If you have an angle that's 90 or bigger, it's not going to be acute. So for instance, we could look here at B. B has that 90-degree box. It's definitely not going to be an acute triangle. We could look over here at C. I see 40, 80, and 60. Well, that's really great. All of those are less than 90, so C is definitely an acute triangle. Coming to D, I see this 140 degrees. Well, that definitely ain't less than 90. D is not going to be acute. I'll come back to A in a second. E, when you see those markings around the outside of any shape really, that means that these sides are the same length. So if you wanted to, you could write in like this is 5, 5, and 5. It is an equilateral triangle. When a triangle is equilateral, it's also equal in angle. Okay? So if something's equal in angle, there's 3 angles. We would do 180 degrees divided by 3. So any equilateral triangle, no matter the size of the sides, has angles that are 60. 60 is less than 90 degrees. Thus, every equilateral triangle will also be an acute triangle. Okay? So these could have been sides of 500 instead of 5. They still have angles that are 60 degrees. My last one is an isosceles triangle. So isosceles means that 2 sides are the same. 2 sides same. So if we know that these 2 sides, the markings over here, are the same, we also know that these 2 angles at the bottom here are the same. If the sides match, the angles must also match. Then if I want to find out what that last angle is, I'm just going to use the fact that I know all triangles add up to 180 degrees, and I'm going to subtract out those 2 70s I've already used, which would leave me with 40 degrees up at the top here. Which means 40, 70, and 70 are all less than 90, so we have another acute triangle. The next question asks about obtuse. Obtuse means that something is greater than 90. A triangle cannot be both acute and obtuse. They are exclusive. So I already know that A, C, and E cannot be obtuse. You could also just look back over them. 40, 90, and 70. 40, 70, and 70. None of those are greater than 90. B has a right angle, but it has no angle that's bigger than that 90 degrees. So this one cannot be an obtuse triangle. The last one we have here, D, that 140 is bigger than 90, so D would be my obtuse triangle. And finally, oh, sorry, we're skipping. Oh, I'm going to skip down to 6 actually, because this is our other type of angle one. A right angle is, of course, equal to 90 degrees. We have one triangle here that has that box. Again, always pay attention to those boxes. They mean 90 degrees, and B would be our one triangle that is 90 degrees. Okay. The next things we have are about side lengths. So there are 3 kinds of sides. The first one we see here is scalene. So scalene means, if I can get my pen working, scalene means no sides equal, i.e. all the sides have different length. So if I go to this triangle, my A, I see I have these 2 markings. That means those sides are the same length. If they have a duplicate length, then we cannot be scalene. Thought I was going to sneeze. Sorry. For B here, I see that none of my sides have any markings on them. With no markings on them, all of my sides are different lengths. Therefore, it is scalene because they are all different. Another way you can check is if all the angles are different. 40, 60, and 80 are all different numbers. Therefore, C would have all different sides. For D, I see the markings that tell me that these two sides are equal, so that can't be scalene. And for E, all of the sides are equal, so that also cannot be scalene. So we'll move on to our next ones. Next we have isosceles. Isosceles simply means two sides, that are the same. So two sides equal. So we can just go through and we're looking for those markings. If I look at A, right, we have those markings there that I've gone over like 100 times. But that's telling me that those two sides are equal, therefore A is an isosceles triangle. Similarly, D, I see the two markings. That means two sides are equal, and that would be isosceles. And hopefully what you can see is we have an isosceles triangle that was acute, and an isosceles triangle that was obtuse. So you can have different kinds of angles and then have sides that are still equal. And finally, which one is our equilateral? Equilateral, that would mean you have markings on all three sides, which is what we have in E. So those are different types of triangles. Equilateral are all the same. Equal means equal, and lateral is your sides, like your side muscle is called your lateral. Okay. All right, the next part, I like some of these questions. They're pretty easy, number 7 and 8. Number 7 and 8 are referring to our picture of triangle ABC. Number 7 says, what angle is included by A to B and B to C? Well, all you have to do is look for what's in between them, and it's B. So angle B is included. Remember that angles can be written a few different ways, so it's possible if this was like a quiz question, you might also see angle ABC or angle CBA. But what you're looking for is that B is just in the middle. Again, that just could come down to how they decide to word a question on Apex for a quiz. And 8 is very similar. I have side AC and side BC. Well, look, what do both of them touch? It's angle C. You could also get that off of the fact that C is included in both of them, and that'll tell you which angle it is. Again, you could write out all of them. Depends on the Apex question. The last two deal with our triangle inequality theorem. So, triangle inequality theorem. This theorem is pretty easy. It states that if your two small sides are bigger than the biggest side, so small, small, large, then you have a triangle. Then a shape is a triangle. So what does that look like in practice? Well, in practice, you're going to be given 3 sides, okay? So my first one, I have 5, 4, and 10. What you want to do is take your 2 smaller sides, so the 2 small ones, and add them together. So 5 plus 4, hopefully we know, is 9. And the question you want to ask yourself is 9 bigger or smaller than 10? Well, 9 is smaller than 10. It gets the small side, which means it fails our triangle inequality theorem. So this is not a triangle because I need that 9 to be bigger than 10. So you add the small ones together and compare it to the big one. do another example here. It doesn't matter the order they give them in. So I see 12, 7, and 10. My two small ones are 7 and 10. Add them together, and I'm going to get 17. 17 is bigger, so it gets the big side of your inequality, than 12. So yes, this would be a triangle. So the triangle inequality theorem is simply add your small ones together and see if they are bigger or smaller than your large one. If there are any questions, let me know.